Right.
Excellent.
Thank you very much. We do have our last presenter. We will give you the full 13 minutes that we have left in the session,
Okay.
But please continue.
Okay,
We'll begin.
I will immediately get started. So, hello everybody, I'm Sauli Kiviranta from Delta Signi Labs. Today we will go through introduction, why we are interested in the DTN work, and the little echoed discussion already today that on the application side we need more awareness of DTN work, and some best practices have been and will be very helpful for the developers. Then we go through findings, and hopefully at the end we have some time to discuss the future steps. So next slide. So our background is virtual and augmented reality, especially in the context of industrial services, working with automotive, energy, maritime, and medical industry and machine building industry. Please, next slide. And we started, or our background is on state research, dealing with machine building industry service operations. We have been involved also with the space industry service operations, as well as robotic services of, for example, ITER fusion reactor. Next slide, please. And one of the use cases we got from the space industry was support of the astronauts, the service operations of the International Space Station, and how we could use augmented reality to help the astronauts so that the engineers could assist in service operations. Please, next slide. As well as the clean room operations that have very much the same characteristics, that it's a place of assembly operations what are difficult to access by the other people who are involved in the design of the system. Next slide, please. And once we started to build our system, we thought that this is going to be walk in the park. We just grab WebRTC, slap a UI on top of it, and call it a day. But as you may expect, this was not exactly the case. Next slide, please. We go to the IT department and they say, no, that's not, guys, this is not going to happen. So shall not pass. Please, next slide. So here we were at the crossroads. So we knew that if you want to do real-time streaming, AR applications have the real-timeness of the video stream up and then the control stream down. But based on the circumstances, we just had to opt with the TCP and go forward that way. Next slide, please. So we didn't know if this is a good idea, but since we didn't have any options really, we wanted to proceed with the project. Let's do it anyway. Next slide, please. And at this moment, we were able to actually deliver our system. We were able to operate, and but we got some feedback from this is, for example, in this case, we were showcasing it at the ESA for the astronauts, and one of the astronaut trainers said that, guys, this is cool for the space context, but what we need the processes and technology fine-tuned on the ground segment. So please go with the traditional industry and let's figure out how to operate in the maritime, in the energy and other fields, and then bring it back to the space. And this was the moment where we realized that this type of a hardware system is not anymore scalable, and we had to go purely software side, and our product Pointer was born at this point. Next slide, please. And once we started to work with the traditional industry, we realized that actually security, for example, in terms of power plants and water purification plants and others, cannot be an afterthought. So this was already an advantage from our perspective once we had to use TCP. And the fact that what we had with the contractors in the clean rooms, that you have multiple, for example, military companies, that we had to be crossing multiple enterprise boundaries when we tried to transmit data between the sites. Next slide, please. And here we come to the context of the DTN, especially that we cannot assume connectivity. We cannot assume good channel stability, and we will be dealing with a lot of legacy systems also. So next slide, please. And the fact that disruptions and disturbances will be just a day-to-day case, it will be nominal. And this is also what we already discussed a bit, the message from me, that a lot more applications should be actually from the get-go adopting the best practices that the DTN working group will be providing. And also mentioned that offline mode, for example, in cargo vessels, there might be satellite connectivity on the deck. but once you are dealing with the engine rooms and other systems in the vessel, that you will be operating offline, and your applications have to be developed in the mindset of very much what bundle protocol is bringing into the picture, that sometimes you will be offline for some parts of the process. Next slide, please. And once we realized all this, we started to work with the European Space Agency on really figuring out the delay tolerance aspect of our system, as well as the disturbance tolerance in terms of packet loss and this situation where we are transitioning during the use of application to the offline mode and back and forth. Next slide, please. And after that project, we were much more confident. So previously, if you remember the system, we were able to deliver, and it kind of did the job, but we absolutely were not ready for the space, for example, deployment to the International Space Station. But now we have much more confidence that it's not only that is it a good idea, but we actually see it working, and our approach brought some nice advantages along the way. So we have delay tolerance as well as the disruption tolerance. We ended up cooking our own internal bundle protocol equivalent, maybe much more primitive version of it, but the story and forward, especially in the offline context, is very important from the application development point of view. And the system design from extremes, especially if we are trying to be a spacefaring civilization, we have to start developing our application from the assumptions that there will not be good connectivity and there will be disturbances and delays. And also this continuous condition measurement is very important. If you go one slide back. We ended up doing temporal and spatial bitrate adaptation for the video streaming. And we realized also that it's very important when you are dealing with DTN type of systems that you have to also communicate, remember to communicate to the end user that what is going on with the network currently for user experience. Next slide, please. So let's take a look at some measurements, what we have now done, what the system we built based on TCP, what we do today. Next slide, please. Here is an example in terms of packet loss. So that what type of a disruption tolerance we have been able to achieve. So on the left side, top left corner, you see a range of packet loss conditions starting from 0% going down to 10% packet loss. And most of this work, what we have done, is inspired by the people who are behind the LTP, the link leader protocol, and a lot of people in the DTN. And we can see that once we walk down the packet loss scenarios, we don't see dramatic increase in the delay, as well as when we are monitoring the output of the channel, we see that the retransmission rates are very much following the rate of our packet loss. And if we plot out these measurements into the graphs, we can see that the behavior of the transmission is very linear. So we don't see any exponential growth or runoffs on the transmission regarding the disruptions. And just for reference, what does it mean to be 10% packet loss? There is a very good measurement by Ulrich Spiegel on Starlink that it corresponds about using Starlink, for example, on a vessel during a storm. So this is related to critical infrastructure where regardless of the conditions, you still have to be able to communicate data. Next slide, please. Then we move to the delay resilience. Instead of walking down in terms of packet loss, now we are focusing on increasing the latencies. And for reference, for example, going around the Earth is about 200 milliseconds, communicating to ISS and background trip, it's about 500 milliseconds. Moon missions, about 1.2 to 5 seconds. And we can here do the same. We look at the average delay, and we see that it's roughly about a round trip. And the 99th percentile, since our packet loss in this test is 1%, it adds on one extra round trip of delay in context of TCP for the 99th percentile. And here in the graphs is something interesting. We see on the delay growth that it's very much linear all the time, and it's nice straight line. And on the output, we see some weird behavior. And this is maybe something that some experts from the DTN working groups might be interested in investigating, that about 800 milliseconds to 1000 milliseconds, we have a step change. Suddenly we have an extra 5% of retransmissions, which is abnormal. Based on the data, this shouldn't happen. So there's something weird going on with the maybe retransmission or this fast retransmission or something else. And the same step change we see at about 3000 milliseconds. Again, massive increase in retransmission. So this might be interesting to investigate for the delay resilience work. Next slide, please. So that was the technical side about the statistics and measurements. So let's quickly go through the future, what we could be doing. If you look at the real-time data transmission and streaming, there is a nice report by WOSA. There are already a handful of protocols that are capable of doing about 1 second latency. We have been able to, with TCP, push it to about 100 milliseconds. And this brings us to a completely new realm of possibilities, especially when we have some resilience on the packet loss side as well as on the latency. And the industry, about 14% of industry is capable of sub 1 second streaming, but 57% of them wants to go sub 1 second streaming. So let's take a look at 2 examples. Next slide. Here's an example of process monitoring and control. So you can imagine this comes from pulp and paper industry, that you have, let's say, multiple sites, about 100,000 sensors updating twice per second. That can be up to 1 gigabit of traffic. And with current technology, you can go to AVS and bring this up. You get about 700 milliseconds latency. But this type of applications are resilience and latency constrained, so that you cannot expect to utilize the same data to control the process back. You need the speed, and also for you to be able to remotely control industrial processes, you need to have the resilience what the DTN working group is bringing. And the next slide. And second example comes from the machine-assisted fleet control. In cargo handling, there are already many harbors that have this type of a concept, that there are hundreds of different cargo cranes. And the actual operators are not anymore sitting with the cargo cranes. They are actually sitting at the side of the harbor in an office. And most of the bulk operations of those devices are being autonomously handled. The devices are driving around. And once the actual work cycle of grabbing the cargo container, then the human operator takes over and performs this delicate act. And these applications are also resilience and latency constrained, that a lot of this work should be centralized so that they can serve smaller harbors, for example, in different cities. And this is simply not currently possible. So again, a lot of this working group advice and best practices are needed so that this type of application can scale more to the smaller deployments and handling multiple harbors from central place. Next slide, please. So this is a big market already. We see autonomous driving. They are also under the constraints, drone operations, maybe metaverse applications at some point, but smart factory and IoT, and our focus has been this industrial services and maintenance operations. So I think DTN is at the core of enabling this market. So word of encouragement to everybody who is working here. And also, I would like to echo what was said by Mr. Blanchett, I believe, earlier about this, that our application developments, it should not be a special case, but it should be rather the starting point that we develop our systems. And this way, we have more and more applications that are actually space operation compatible once we reach for the stars. Thank you very much.
Thank you. I know that we are 1 minute past, but and I appreciate your patience. We have one person in the queue currently. Rick, go ahead.
Thank you very much. It's a really nice presentation, really interesting. There's some crossover here in what you're presenting between DTN and also what's happening in the IETF in deterministic networking, where a lot of work is going into ensuring that certain bounds on the characteristics you're getting out of the network are there, particularly for factory automation, particularly those remote examples you were using of VR telepresence, a lot of the things here. and also the sub-branch of the deterministic networking group, the reliable and available wireless group, which looks at adding that layer of determinism across wireless bearers. So particularly disruption in terms of RF interruption, busy factory floors, and all that kind of remote automation stuff you've covered. So I suggest you also go and look at some of the deterministic groups as well as DTN, but great presentation.
Sure.
Thank you very much.
Thank you, sir.
And we have one more, Josh.
Hear
We
me?
cannot hear you. Oh, we can hear you now.
Can you hear me now? Okay. Do you happen to have any more information that you can share with us regarding the delay resilience for LTP?
Yes.
Because I've been doing some testing in and of myself right around the 4-second delay range. And I'm seeing slightly different stuff. There is an exponential increase on when you start losing data. It does cause problems the higher the delay is for obvious reasons, because it just takes longer time to catch up. But if there's any extra information you can share regarding that, that would be amazing.
Yes, please feel free to reach out after. Unfortunately, you are not here, so I'm here for the rest of the day for people who are interested about those measurements. So I will be on the corridors, so we can just take a look, hands-on demo, and play around with the system to see how it works. But for you, since you're remotely, so feel free to please reach out for me, and I will be happy to share more information about that.
And please as well to share on the mailing list, because I know we have many people who have made similar observations. Thank you so much. We are just about 5 minutes past, but again, excellent working group meeting, and look forward to seeing everyone in 117. San Francisco.